When a ray of light travels from denser to rarer, the bending takes place away from the normal. We all know that the refractive index is not same for all the mediums. So it also depends on the refractive index of the medium. This phenomena of bending of light ray when it travels from one medium to another medium is called as refraction of light. Hello everyone, welcome to session 3 of chapter 9 Ray Optics and Optical Instruments. This is Swati from Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the last session we have discussed about the various phenomena of light such as reflection and the properties of light, that light undergoes rectilinear propagation. In today's session, let us start with the another property called refraction of light. So what is refraction of light? How is it different from reflection? Though they sound similar, there are two different properties of light. What is refraction? So when a light ray travels from one medium to another medium, or when it travels from, in this example, it is traveling from the rarer medium to denser medium, we can observe the bending of light ray takes place. So this phenomena of bending of light ray when it travels from one medium to another medium is called as refraction of light. So refraction takes place even if the light travels from denser to rarer medium as well. But certain conditions applied. So now in this diagram we can observe this is the incident radiation. This is the surface where it meets the normal, and this is the reflected ray where the light ray goes back to its original medium. But in this case, this is the refracted ray and we'll call this as angle of refraction or refracting angle. So this is angle of reflection or reflecting angle. So this angle between the incident ray and the normal is called as incident angle. So let us now see the definition. So when a ray of light is traveling from one medium to another medium, the phenomenon of bending of light ray is called as refracted ray. What if the light ray travels from denser to rarer? Or if the light is traveling from rarer to denser, how they are different from each other? I mean the two cases, how they are two different cases. So let us see now. So when a ray of light passes from rarer to denser medium. In the first picture, you are seeing that the ray of light is traveling from rarer to denser medium. The bending of light ray takes place towards the normal. The light ray bends towards the normal when a ray of light traveling from rarer to denser medium. Whereas in the second case, you can observe the ray of light is traveling from denser medium to rarer medium. The arrow mark indicates the direction. So it is traveling from denser to rarer. The refracted ray or the ray of light refracts, or the bending of light ray takes place away from the normal. You can see here it is taking place away from the normal. So this is the major difference. When a ray of light traveling from rarer to denser, the bending of light ray takes place towards the normal. When a ray of light travels from denser to rarer, the bending takes place away from the normal. So both the cases are due to refraction. So the next condition, if a ray of light incident normally on the surface separating two different media, this is a air medium and this is a glass medium. If a ray of light traveling normally without any angle, if it is incidenting normally on the surface, it passes undeviated, which means it passes normally even after it changes its medium. Let's move on to the next important thing in refraction of light or in the study of light, that is Snell's law. So what is the statement of Snell's law? First law of Snell's law says that the incident ray, the refracted ray and the normal to the interface at the point of incidence all lie in the same plane. Similarly, we have studied the first law or the Snell's law or the laws of reflection in case of reflection as well. So there also we have studied the same thing. Here also the first law says that the incident ray, the refracted ray and the normal to the interface at the point of incidence all lie at the same plane. And the second law says that the ratio of sine of the angle of incidence to the sine of the angle of refraction is always constant for a given pair of media and for a given wavelength of light, which means sin I by sin r is equal to n to 1, which means refractive index of medium 2 with respect to 1, which is nothing but n2 divided by n1. So we can even write it as n1 sin I is equal to N2 sin R. This is the second law, which is very important. So we shall study the next concept, that is the consequences of refraction. What are the consequences of refraction? So the two consequences importantly are lateral shift and normal shift. Lateral and normal. The name itself says how the shift is taking place. So first thing, lateral shift. When a ray of light passes through a parallel sided refracting medium, the perpendicular distance between the emergent ray and the incident ray is called as the lateral shift, which means, suppose if this is a parallel sided refracting medium, this is my angle of incidence. So when it strikes this surface, it undergoes refraction, which means the bending takes place. Again in this surface, it undergoes refraction, the bending again takes place. So this is called as emergent ray. But what is the original direction of incident ray? So this is the original incident ray. Now this is the actual path of the incident ray, but after undergoing refraction, the ray is emerging out in this way. So now if you calculate the perpendicular distance between the incident ray and original direction of the incident ray and the emergent ray, so this perpendicular distance gives us lateral shift. You can even refer this diagram, you will understand this is the original direction of incident radiation and this is the emergent ray. The perpendicular distance between these two rays gives us lateral shift. So next one is, what are the factors on which this lateral shift depends? It depends on the angle of incidence. It also depends on the thickness of the medium, and it also depends on the refractive index of the medium. We all know that the refractive index is not same for all the mediums. So it also depends on the refractive index of the medium. Now what is the minimum value of lateral shift? The minimum value of lateral shift is 0. So when can we get 0 value in lateral shift? There is no lateral shift when the ray is incident normally, because we know that when the ray incidents normally, it passes undeviated, and hence there will be a 0 value, that is a minimum value when the ray travels normally. So the next important consequence is normal shift. As the name says, normal shift, that shift takes place normally. So where do we observe all these things? Let us see an example. So what is normal shift? Apparent shift in the object position kept in one medium and it is viewed normally from the another medium is called as normal shift. Say for example, we all have observed this in a fish tank. This is the actual position of the fish, but when we normally view the fish from the surface, which is from the another medium, it appears to be shifted to another position, some different position, and we assume that this is the actual position of the fish. But it is the apparent shift in the position of the fish in the fish tank. So that optical illusion is due to normal shift. So now this is the original depth of the fish, but it appears to be at this position and we'll call it as apparent depth from the surface. So basically apparent shift of the object when it is placed in one medium, and when we view it from the another medium, we observe the shift in its position, and that shift is called as normal shift. What are the factors on which this normal shift depends? So it depends on the real depth at which the object is present. The real depth, say for example, in this example, I have placed a coin on the table and there is a glass slab here. When the observer observes this from the another medium, it appears to be shifted to this position. So this is called as apparent depth. So it depends on the real depth of the object which is present, and it also depends on the refractive index of the medium where the object is kept and it is viewed. Because when the object is placed in one medium and it is viewed from the another medium, there appears to be a shift in its position. We'll call it as normal shift. So it obviously depends on the refractive index of two different medium where the object is placed and where it is viewed from. So in this session, we have learnt about the phenomenon of light, one of the important phenomena, that is the refraction of light and the consequences of refraction, as well as the Snell's law. In the next session, we shall learn some more interesting concepts. Until then, keep learning all of you. See you all in the next session. Thank you.